Okay, Algebra 2, this is the second half of the notes, or of the Chapter 9 review for the Chapter 9 test. Yesterday we did the front side, now we're going to do the back side. And here we go, let's just jump right in. Number 16. They ask for a positive angle and a negative angle that are coterminal. And coterminal means they're at like the same stopping point. So if you remember when we talked about this, when we did this section, that like if I have an angle that is, let's say, 20 degrees right here, like he's in the first quadrant, 20 degrees. If I would go one more cycle around, like adding 360 to that, 380 degrees would be the same stopping place as what 20 degrees would be. So those are considered to be coterminal, okay? So what's going to involve with each one of these four problems here, starting with 16, is that we can either add 360 degrees or subtract 360 degrees to get a coterminal angle. And they're just wanting me to do that process until I find one positive, one negative. So if I add 360 to 65, that would give me 425 degrees. So he's going to be at the same stopping place as 65 degrees. But also if I take 65 and I subtract 360, that's like 295, I think, or something like that. Negative 295 degrees. He is a negative angle that would also stop at the same place as 65 degrees. Now, those aren't the only two answers. You know, if you wanted to do another 360, you know, technically 785 could be a positive one also. So you could use 785 instead of 425. I don't know why you would, because you have to do 425 anyway. But I had like, I don't know, students in the past that just want to make me have to think, and they'll add it 3 times and list that one as the angle rather than listing the first one that happens. So you can add and subtract 360 as many times as you want. It doesn't really matter, just as long as it's 360, and that'll give you a positive and negative one, okay? All right, 17. If I add 360 to negative 75 degrees, that is a positive 200, and I gotta think, 285. Let me add 360 minus 75 is 285. Yep, 285 degrees. So that will give me a positive one. Then if I take negative 75 and I subtract 360 going around the other direction, that will be... my brain's not working. 432 or 435, and that is a negative angle, negative 435. So those ones will work again if you want to do more than one cycle around for adding 360, subtracting 360. We're just trying to find the stopping place. When it says coterminal, that means same stopping place, okay? All right, 18. If I add 360 to this one, I can do that in my head. 590 degrees will give me a positive one. And if I take 230 and I subtract 360, that will give me negative 130 degrees, I believe. So those are all coterminal. They all have the same stopping place as 230 degrees. Okay, now there's one tricky one on number 19, and it is this, that if you add 360, okay, let's do this. Let's add 360. That would give me 780 degrees, would be coterminal with 420. So they would have the same stopping place. Now, if I take 420 and I subtract 360, I'm going to get a positive 60 degrees again. So I end up with 2 positive angles. They're both positive, right? They're coterminal. They're at the same stopping place, but they're both going to be positive because 420 is such a large angle to begin with. So what I have to do is, in order to get another negative one, or to get a negative one, I have to subtract 360 again. And this would give me negative 300 degrees. So I'm going to use like negative 300 degrees and 780. Or I could do negative 360 degrees, as long as I have one positive and one negative. But that's one where you have to subtract 360 twice, at least, before you get your first negative angle, if that makes any sense. It's kind of like on a number line, like 420 lives here. You could keep adding 360 or subtracting 360, and any of these would be coterminal angles. But it's just that, like, this would be 60 if you subtract 360, and then you'd have to go all the way down to this point to get your first negative angle. Okay, so if it helps you to think about it as a number line, that's how that works. Okay, so when you have large angles like that, you might have to add or subtract 360 multiple times before you get a positive or a negative one. Okay, all right, we're 6 problems here under this instructions. Rewrite each degree measure in radians or each radian measure in degrees. Okay, and so when we did this to begin with, we talked about how the circumference is equal to 2 pi r. And if your radius, I think we said if our radius is 1, then the circumference of a circle is equal to 2 pi. Well, the circumference of a circle in terms of degrees is 360 degrees, right? So 2 pi is equal to 360. But if that's the case, I can divide by 2, and we know that pi is equal to 180 degrees, right? So like going around the circle, 180 degrees or half of the circle is equivalent to pi in radians. Okay, so that's where they get the conversion that when you're converting between one or the other, you're either going to use 180 over pi or you're going to use pi over 180 because those two things are equivalent to each other, and that's how we do the conversion. Okay, so up at 21 or 20, I always start by making my degrees as fractions. So I put them like that, and then I want to use either this one or this one to convert him, okay? And what I want to have happen is if this is a degree up here, I want him to cancel with a degree down here. One has to be on the top and one has to be in the bottom. So I'm going to put my 180 degrees on the bottom, and then pi has to go on the top. Okay, so that's how I make the decision between which one is that if degrees is here, then degrees has to go here. Okay, and then all I'm going to do is reduce. So I know I can cross a 0 off. Okay, don't multiply this through and make a decimal number. Don't make a decimal. 14 and 18 can divide by 2, so that becomes 7 and that becomes 9, and then your answer will just be 7 pi over 9. You'll have pi in your answer because now this went from being a degree to being a radian now. Okay, and radians usually have pi in their answer. Okay, at least the ones that you guys will do. We eventually, like in trig class, we'll get to the point where we deal with radians that are not in pies, in units of pi, and those are kind of icky. So we'll save that for trig class. Okay, put this over 1, and this is a degree, so I'm going to want to switch it to a radian. And so keep in mind that there's a negative there, so my answer at the end will just end up being a negative answer. All right. Oh, I don't know why I put an equal sign here. Cross that off. Times, I want to put, if degrees is up here, I want to put a degree down here, so that means 180 has to go on the bottom and pi has to go on the top. My degree symbols will cancel, and so will my zeros. I can cancel a 0 off. And then I look at 26 and 18, and those are both divisible by 2, I think is the largest. So this would be 13. Make sure the negative goes with it, so negative 13 over 9. So negative 13 pi over 9, and I think that is as far as you can reduce. So that is what the radian version of negative 260 degrees is. Okay, that was 21. 22, this is a radian, and now we have to switch it to a degree. Okay, so when I'm doing this, he's already a fraction, so I don't have to make him into a fraction, but what I see is that pi is here, so I want to make sure that pi is in the bottom so that they will cancel off, right? And if I put pi in the bottom, then 180 has to go in the top. Okay, and then all I'm going to do is reduce and multiply and do all that stuff, and then I'm done, right? So you could, if you wanted to, take negative 3 times 180 and divide by 5. I'm going to reduce to begin with, so like 5 is here, that can become a 1, and 180 divided by 5 is 36 degrees, I think. Then all I have to do is take negative 3 times 36, because my bottom, everything's gone on the bottom. Negative 3 times 36 is 90 plus 18 is like 108, negative 108 degrees. There you go. So that's what he is in decimal or in degree form. Okay, and make sure the negative goes with it. So if your starting number is negative, your ending value will be negative. Okay. All right, down here, this is a degree. We got to switch to radians. So I'm going to make him into a fraction over 1 times. I want to put the 180 on the bottom. 180 degrees. I want to put pi up here, and the degrees are going to cancel. And then 75 and 180, if I divide by 5, 75 divided by 5 is negative 15, negative 15. And 180 divided by 5, I think we said was 36 just a minute ago. Oh, but wait a second. I can divide bigger than that. 15 and 36 now will divide by 3. Right? Yes. So 15 divided by 3 is -5, and 36 divided by 3 is 12. So I have -5 and pi on the top, and I have 12 on the bottom. So there we go. Sometimes you might have to keep reducing if you don't choose a big enough number to begin with. So I should have probably divided by 15, I think, to begin with, probably, instead of dividing by 5 and dividing by 3. Anyway, so -5 pi over 12. This one is a radian. We're going to degrees. And I'm going to put pi on the bottom so that he cancels here and cancels here, and 180 goes on the top. And then I'm going to reduce my 6 and 180 and become 1 and 30, and then all I have to do is multiply 7 and 30, which is 210 degrees. There we go. Okay, last one in this section. Over 1 times, we have, I want to put 180 on the bottom so that the degrees will cancel. Cancel, cancel. Pi has to go on the top then. And then I'm going to reduce, so I can cross my zeros off. 38 and 18 I know will divide by 2. So if I divide by 2, that's 19. If I divide by 2, that's 9. So 19 pi over 9, I think, is what will do it. I think that's what will happen. Okay? All right, now this section is a doozy. And then we've got an easy section down below, hopefully. All right, this one's a doozy. We've got to draw a picture of this one. So we've got 8 and 4. If I put that on a coordinate plane, that means I'm going 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going 4 up. So he is a dot that looks like this. And then what I do is I connect him back to the origin. And then I make him into a triangle. Okay, so there is my right triangle. This side of the triangle is 8, and this side of the triangle is 4. Okay, then what I want to do is I want to find what this third side is using the Pythagorean theorem. This is kind of a lot of work for some of these. All right, so 8 squared plus 4 squared equals c squared. This is 64 plus 16. And if I add those together, that is 80 equals c squared. And what I'm going to do is I'm just going to leave him as the square root of 80. We could break it down further than that, but I'm going to leave him as the square root of 80. We're just going to do that, okay? And then they want us to find the 6, holy cow, the exact value of the 6 trig functions. Holy cow. All right, we've got sine of theta. Where does theta live? He lives down here in this corner always. He lives right close to the origin, 0, 0. So we've got sine of theta. We've got cosine of theta. We've got tangent of theta. We've got, which one? Cosecant. Cosecant goes with sine. The C's and the S's go together. I don't know why that is, but somebody in the math world screwed that up once upon a time. I would have made the C's and the C's and the C's go together, and the S's and the S's go together. But whatever. They just want to not make sense, I guess. Anyway, so there's that. All right, so let's do our fractiony things, and then we will move on to the next one. So here's angle theta. This is opposite, adjacent, hypotenuse. That's how we're going to label those guys, okay? So for our SOHCAHTOA, S-O-H, C-A-H, T-O-A, we just got to write them all out. SOHCAHTOA, okay? O is 4. Hypotenuse is the square root of 80. And how about for just this problem, we don't rationalize because I'm going to run out of room. So we're just going to leave it as 4 over the square root of 80. Technically, we want the square root of 80 on the top, but we're just going to leave it the way that it is. Okay, and then when we flip it, we're going to do 80 over 4, and that's what cosecant is. Okay, cosine is AH. A is 8. Oh, I'm running into each other. H is the square root of 80, and then we have the square root of 80 over 8. Okay. Tangent is OA, so 4 over 8, which does reduce to 1/2 if you want to reduce it. Okay, and then cotangent would be 2 over 1 when we reduce, or just 2. You could write it as just 2. That would be fine too. Okay, all right, so I'll let you not have to rationalize those ones because those ones are, otherwise we're going to run out of room. Like I don't have enough room for that. Okay, 26, all right, 27, here we go. 4, 4 is still in the first quadrant, so I would go 4 over, 1, 2, 3, 4, and 4 up. and he is right here. And I make my triangle. I could have made him bigger. 4 is here on the bottom, and 4 is here on the side. We've gone 4 over 4 up, and we have to find our C value. So 4 squared plus, this is the Pythagorean theorem. Okay, if I'm going too fast, like, and you guys are just confused, just pause this video and then you can catch up. Okay, 16 and 16 is 32, and if we take the square root of 32, it does not come out nicely. We'll just leave him as the square root of 32. Okay, he does break down a little bit further than that, but we'll leave him as the square root of 32. Okay, so we've got sine of, where does theta live? Down here in the corner. Let me make him a different color. Sine of theta. So sine of theta, cosine of theta, tangent of theta. Okay, and we got cosecant, secant, cotangent. Well, it takes just as long to write those out as it does to actually solve the thing. All right, here we go. SOHCAHTOA. I should have put them on here for you already. All right, sine is opposite hypotenuse. Our opposite side is going to be here, and our hypotenuse side is going to be here, and our adjacent side is going to be here. So we've got 4 over the square root of 32, and we're going to leave it. And then we've got the square root of 32 over 4. So don't worry about rationalizing that, okay? Cosine is 4 over the square root of 32 as well, because the bottom side is 4. That's interesting. The square root of 32 over 4, and then tangent is opposite adjacent, which is 4 over 4. You can reduce that to 1 if you want. And then cotangent, that's kind of interesting. If I do 4 over 4 and flip it, it's still 4 over 4, which is also 1. So cotangent and tangent are both 1. Okay, all right, here we go. 2 left of these icky ones. Icky, icky, icky. All right. Okay, this one's a little bit harder. 0, 4. 0, 4 means I'm not going left or right at all, and I'm going 4 up, okay? And so the way that I think about this is that, okay, what I'm going to do is I'm going to cheat a little bit. We're going to make this into a triangle, but I'm going to say that he's 0 over and 4 up, right? Like gone 0 over 4 up, even though 0, 4 should technically be over here. I'm going to slide him over to the side, but I'm just going to label that side as 0, right? So if I do that, then I have my a squared, b squared, c squared. I can say 0 squared plus 4 squared equals c squared. That's 0 plus 16. And I can take the square root of 16, which is 4 again, right? And so this hypotenuse side would be 4. So if it helps you to think about it that way, to think about it as a triangle that has like 0 as his bottom side, and we can cheat and make him look that way. And then when we go to do sine, cosine, and tangent, it will look a little bit nicer, okay? So here we go. Let's do sine. My theta is here. Sine of theta equals, cosine of theta equals, tangent theta equals, cosecant, secant, cotangent. We get line, 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 line. These ones are taking a while. All right, but you'll be all practiced up. Like you will be good to go. No questions about it. They do ask for this stuff a lot on like standardized testing and for like ACT stuff. So if you are A-okay comfortable with this, you're going to be just awesome for the ACT stuff when they ask you things like this a few years from now, whenever you take the ACT. So if that's my theta, then my opposite, adjacent, and hypotenuse are going to be here. All right, so sine is opposite hypotenuse, which is 4 over 4, which reduces to 1. Cosecant, if I flip it, is also 4 over 4, which is 1. So that one's kind of exciting. Cosine is adjacent over hypotenuse, is 0 over 4. And 0 divided by anything is just 0. Okay, this one, if I flip it and make it 4 over 0, anything divided by 0 is undefined. So that's what secant is an undefined value, all right? Tangent is opposite over adjacent, so 4 over 0, which is undefined again. Whoa, I don't know why it's doing that. Okay, undefined, because we're dividing by 0. And then cotangent would be 0 over 4, which is just 0 again. So that's how he looks. Okay, so again, we cheated by making him into a triangle, even though he's not really a triangle because his bottom side is 0, but we'll just make him look like that to make it easier to calculate. Okay, all right, 29, last one, 6, 2. We're getting closer. 6, 2, here he is. 6 over 2 up. Here's my right angle. And theta lives here. And if we do 6 squared plus 2 squared equals c squared, we've got 36 plus 4. And that's 40. So we'll write him out as the square root of 40. Okay, sine of theta, cosine of theta, tangent of theta, cosecant, secant, cotangent. All right. I'll pause for just a moment so you can get that all written down, and then we'll do all of our math, and we'll move on to the next section, and then we'll be done. Okay. When we do our opposite, adjacent, hypotenuse, that's how we'll label those sides. So sine will be opposite hypotenuse, 2 over the square root of 40, or the square root of 40 over 2. And we'll leave them like that. Cosine is 6 over the square root of 40, or the square root of 40 over 6. And tangent is opposite adjacent, which is 2 over 6, or you can write it as 1/3 if you want to, because that's how that will reduce. And then cotangent will be 6 over 2, which reduces to 3. So that's how that will work out, okay? Now, you cannot reduce the 40 and the 2 because the 40 is trapped underneath. So if you were trying to do that up above, that's something that you can't quite do, okay? So that was 29. All right, let's do reference angles and be done. Sketch each angle, then find its reference angle. Okay, we'll talk about reference angle. I don't know if I said it before, but I call it the bow tie angle. Bow tie angle. All right, so we're looking for the bow tie angle, 155 degrees. If we start here and we go up this direction, that would be 90 degrees. And if we go all the way over to here, that's 180 degrees. So we don't want to go all the way to this edge. We want to go just not quite that far. And we want to go, that's 155 degrees. Okay. Now the reference angle is the angle that you would, like, if I had a dot here and I made him into a bow tie angle, like this little guy, you know, like where my bow ties look like this, right? Like that's my bow tie. There's my circle in the middle. He's a bow tie. I make that bow tie angle, and we want to find out what this angle is, okay? So if from here all the way to here is 180, and I'm only going 155, I could just take 180, subtract 155, and that would give me that bow tie angle. And that is, I don't know, 25 degrees is that reference angle. So that's what they're meaning by, what is the reference angle? If I would go the rest of the way to make that bow tie, what would that angle be? Okay, so that's how that works. All right, 31, 230 degrees. If I start here, I go here, that's 90 degrees. If I go here, that's 180 degrees. 270 degrees is down here. So I want to not go quite 270. I'm going to put him over here, and that is going to be 230 degrees. Now, when I make my bow tie, I'm going to make him going up that direction. And I want to figure out what this angle is right here, okay? So this one you have to think about a little bit differently. 230 degrees is from here all the way to here. If I'm going from here to just that point, that would be 180, and then the rest of the way is my bow tie. So in this case, instead of subtracting from 180, I'm going to take 230 and subtract 180 from that, right? So here I was subtracting 180 minus my value. Here it's my value minus 180, okay? And 230 minus 180 is 50 degrees. So this angle right here would be 50, okay? That's my bow tie angle. Your reference angle will never be negative. So there's how that works, okay? 2 more, and those are in radians. So we've got to convert to degrees first. So I'm going to put 180 over pi, and the pi's are going to cancel. And then I'm going to reduce the 3 and the 180 becomes 1 and 60. And if I multiply by 4, that is 240 degrees. Okay, I'm going to do the same thing over here. I'm going to go 180 over pi, where my pi's are going to cancel. My 6 and my 180 can become 1 and 30. And 30 times 11 is 330 degrees. So now those guys are ready to be graphed. Okay, let's graph them quick. Starting here, this is 90. This is 180. 270 would be down here, so I don't want to go quite to 270. I want to go 240. 240 is here. And again, we're looking for this angle right here. This one right there, whatever that angle is. Okay, from here to here is 180. And from here all the way over is 240. So if I subtract those two, that will tell me what my bow tie angle is, which is 60 degrees. That's the reference angle, okay? All right, last one, 33. We are in at 330 degrees. So here's 90, 180 goes here, 270 goes here. If I would go all the way or the rest of the way, that would be 360, but I don't want to go quite that far. I want to just go to there, and that is 330 degrees. 30 degrees, okay? So I want to find out what this angle is. If I would go the rest of the way, all the way through, that would be 360. So I am like, if it helps you to think of it, I'm taking 360 minus 330. I am 30 degrees short. That's the reference angle. I'm 30 degrees short of a full circle. That's my reference angle, okay? Holy cow, that was a lot. Woo. Okay, so there you go. That was a lot of review problems. The test is not going to have near that many problems, but I gave you like 14 of each type of problem just to review over and go through. That was a lot of work. So thank you for your patience. There you go.